in what? That's just one of the applications. What is coding? What is computer coding? All those are just ideas. Yes? That's still very close, but it's exactly what it is. When you are close, you are more closer than this one. Who else? What is computer coding? What is computer coding? Who else has a very sharp idea of what that is? What is computer coding? Yes? Huh? Okay, now everybody, now I want you to pay attention to what I'm about to give you here. Are you seeing the screen from there? That's why I give everybody numbers so that going by your numbers, you need to have, you know, one-on-one. The classroom will be much more interactive than being chosen. I think it's okay like that, right? Yes. So now, look at this. Everybody, look up to the screen. Look up to the screen. Now, look at this simple definition. I want to draw this presentation on each of the computers. So with time, whenever you come, you can read it. Then when you create your email, I'll send you a copy of this presentation. Okay? Is that okay? Yes, now look at what this thing says. It says, what's a computer? It's an electronic device stored in its own memory that can accept data, process data, produce results, store the results. You don't need to memorize everything. The key point is just what you need when we are defining what a computer is. Is that understood? Let's go. Now look at this now. What you are seeing on this screen, can you see the screen from there? Now those of you at the edges, take your seats. Come and occupy this. What is a computer? So what is a computer? Like I'm writing this my presentation, alright? Now here you see it's an electronic device. It accepts data, it processes data, it produces results. Now, these are the kinds of devices we have. I want everybody to be looking up, nobody should be looking down. Eyes on the screen, all eyes on the screen. These are computers, this is a printer. As you can see, this is a palm device, it's also an electronic device, it's a computer as well. This is a screen you can see. That's some of the examples are there. Now, it continues. This is a complete system. This is a desktop. You can see this is a server. This man is operating on a server here. This is also a device. These are devices. Now let's go to the next slide. These are computer systems. They are only functional if there is hardware. That's what this slide tells us. Now over here we have the basic hardware components. We have printer. What do you call that box? Anybody? Do you know what it's called, the box?
CPU.
System unit is not CPU. It's Nigerian language when it's picking up when you say it is a CPU. CPU is only one of the components of the system unit. Is that understood? Yes. Good. Now look at this. This is hardware components as well. Then here you have the hard disk and some other devices mount that you can recognize. This is camera. Is it still recording?
Yes, sir.
It's when it's done with the recording, then if the red light stops, just call my attention now. So here we have some of those other devices as you can see. That's not my eyes. Some of them are here my eyes. I'm not selling ice cream. So here you have some of the ports. Okay, you have ports here. These are some of these ports. You might identify them or see them when you're working on the computer. These are serial. And this is PS2. This PS2 drive, but this one's are spaced out. They've been trying like this one now. It's now been replaced with USB. These are other serials. These are all serials. There are types of serials. And it goes on. Look at this port here. You can see the name of the port here. And then this is the VGA port. This blue one. It's usually VGA port. Called video. What's the meaning of VGA? Who knows? What's video? What? Graphics adapter. Write it down, everybody. VGA means video graphics adapter. Video graphics adapter. No, don't adjust anything. Just very simple. Video graphics adapter. That's what VGA means. And this is it here. Alright? Good. So let's go on. Now look at now. This is what we call system ports. Your system ports. You can see the back here. It has ports, serial ports there. Alright. When you have them on your emails as your private copy, I'm going to go over them and get to understand what they really are. Now let's talk about the software which you are actually here for. Alright. A software cannot work without knowing this knowledge of the hardware. So here, the software is a set of programs which is designed to perform what? A well-defined function. A program is a sequence of instructions written to solve a problem. Everybody read that together and let me hear you.
Software is a set of programs which is designed to perform a well-defined function. A program is a sequence of instructions written to solve a particular problem.
Okay. So, any questions about that? Questions as regards that? It's a clear thing. It's a program, okay, that executes instructions. It executes functions. That's what it is. Now let's go on. Now application software. Everybody read that together. 1, 2, go.
Application software is designed to satisfy the particular need of a particular environment.
Read on. Go on.
Application software may consist of a single program, such as the Microsoft Notepad, for writing and editing.
Let's continue. Alright, so let's just continue with what we are doing quickly. So let's run. Now look at this. Everybody read this out. Proprietary software versus open source. This is what it is about. Now, proprietary means that it is commercial. You can write that down. Proprietary software are commercial software. Proprietary, look at the spelling here. As proprietary, anytime you see or you read up something, the author refers to the software as proprietary. That means it's private. It's for private use. It's corporate owned. It's for commercial purposes. All right. It's owned by an organization. That's proprietary. Now, that's open source. Open source is free. Might not be free in the sense that to acquire as your own for you to use. It is free, open source. Alright? Now, let me give you examples of the closed. The closed source, the very popular closed source, hello, listen, pay attention to this. Proprietary. The typical example of that is Microsoft. Microsoft sells its operating system. It's not free. You have to buy many components. Open source, the typical example of open source is Linux. Like the Linux environment. Linux is one of the operating systems that has variants. You have Red Hat, you have Ubuntu, you have OS, you have Kali Linux, and so many of them. And those ones are open source. You can easily download from the internet and use once you know how to download and install. Okay, that's what open source is. Closed source is what did I say it is? It provides source and then it's what? Commercial for private organizations. Okay, that's what it is. Now, quickly read this. I want you to read this first part. Let me hear. 1, 2, go.
They are which means that they are used for notification and architect.
Yes, that shows that it is private. So you cannot just walk in and pick it up. You need approval, you need to purchase it or do some other thing. Now, read this first line in the first paragraph. Let me hear. For the open source.
Users cannot afford proprietary software or prefer software that can be globally modified and choose to use open software. Open source free and open source for us.
Good. So what is open source? What is open source? Can you give us examples of open source? What is that? Can you, in your own words now, what is open source? Huh? That's an example. But what is it itself? These are types of operating systems. Write it down. Types of operating systems. You have proprietary operating system, then you have open source. The proprietary is private, it's organizational, it is restricted. Okay? Meanwhile, are you writing? Meanwhile, the open source is free. You can easily download it from the internet and use it. That's what it means. It's very simple. And examples of proprietary is Microsoft Windows. Example of closed source is what? Linux, all the Linux variants. I mentioned examples like Red Hat, CentOS, Ubuntu, Ubuntu. So there are so many others like that. Let's quickly go on. So we will not waste time. So now examples and types of software. You can see this. Look at Microsoft Windows, Windows 7. These are proprietary. All these ones here. Apple. These are all proprietary. These are another example of closed source. You can see them. To purchase most of all these things, all these ones we are seeing here, they are usually for sale. Or like the free ones, like ones you can have to just connect to the internet and then you download and start using. Now, quickly read this. Let me hear. This is relationship between hardware and software. Someone is where everybody wants to go.
Hardware and software are mutually dependent on each other. Both of them must work together to make a computer produce a useful output.
Read this. Read this.
Relationship between hardware and software. Software development is very expensive and is continuing expense.
Is a what?
Continuing expense.
Continuing expense. What it means is that it is painstaking. For you to develop a software, you need a lot of resources. You need finances, you need electricity, you need internet. You saw the little thing that we went through now, just to set up this small class for this time. Okay, to install, you have to get components together, connect everything, camera and other things to do. So that's part of what software is about. You see it, no worry. You see it. When you get home, you eat beans, then you go to home. So let's go on with this. What's the second one? Read this page.
Different software applications are reloaded on the hardware to run different jobs.
Good. The next one.
The software acts as an interface between the hardware.
Good. The next one.
If hardware is the heart of the computer system, then software is the soul. Both are complementary to each other.
I hope you're understanding that.
Yes, sir.
It's clear.
Yes, sir.
Let's go. Now, in summary, these are some of the coding languages that you can use to develop software programs. Alright? The first one here is Microsoft .NET framework languages. That this is the then you see that Microsoft, their applications are Microsoft-based applications like Microsoft Word, Excel, PowerPoint, and the right there. This is the computer language that is used. And the language is called Word. Read it, everybody. Framework languages is a group, is a suite of languages. C# is there, you have F#, you have VB.NET. These are key languages used to build Microsoft applications or Microsoft operating systems. Is that understood?
Yes, sir.
Let's go to the next one now. Now the next one is saying here, everybody repeat out PHP and
PHP, SQL,
Apache.
open source web apps.
That's the description. And what is it used for?
Web development.
Good. We are number 3.
Java,
Java, yes, Java. There is let me explain that. JavaScript. There is Java that you use to write native apps. Native apps, write your note. Native apps. These are apps that are not connected by default to the internet. Native apps. These are apps that are software apps that are not connected to the internet. That's what native apps are. Okay? You get that? Now, web apps. The second definition now, number 2, web apps. Web, that's W-E-B, apps, application. Apps is short for application. Web applications are the type of applications that can connect to the internet, that can only work exclusively when they are connected to the internet. They cannot work without the internet. You need some form of internet connectivity for it to work. Those are web applications. Examples are Facebook, Twitter, your TikTok, those are all web apps, alright? They cannot work without internet, they have to be internet connected. Now, the third one is hybrid, H-Y-B-R-D, hybrid applications. Hybrid applications combine internet and offline features to function. That means they can work offline and they can work online. Those are hybrid. So I've mentioned 3 types now. 1, native. 2, web apps. 3, what? Hybrid. The hybrid combine offline and online features to function as a program software. Those of you that didn't write today, I'll check your notes next week. Write all these things down. Make sure you form your own notes. application. Alright, so let's go to the next thing quickly. What's the next thing here, everybody?
C++.
Now, before we go to the C++, the Java can write native applications that can work exclusively without internet connectivity. The JavaScript works more online. They work online. They work what? Online. You use it to develop web applications. That's what they do. Now, let's go to the next thing quickly. What's the next thing here? Read it out, everybody.
Android, Java.
Kotlin. These are languages. These are computer languages. All these things here in this column here, this logo column here, and this one, they are all computer coding languages that is used to develop what? Software programs. Software what? Programs. So you need to memorize. They will ask you, mention one programming coding language. You cannot mention any of these. We'll do for you. Definitely put that in there. Alright, so let's go on quickly. Are we following?
Yes, sir.
Good. So the next one, number 5. What's number 5?
C++.
Good. And what's the description there?
For create electronic hardware.
Is everybody following? Oh yeah. What's number? Everybody, one, two, go.
C++.
Then the next.
For create electronic hardware.
Good. You should write that down in your book. So you're still going to have this. I'm going to send this to email, right? So everybody will have to can read at home. So then the last thing there is what? Oracle. Everybody read it together.
Oracle SQL.
Good. What is it? So that ends today's lecture. So I'll see you next week. Call the new one, what's it? So then, before you go, what did you guys do? Someone should wait, everybody, wait. I want to snap everybody. Wait, everybody, wait for the camera.